Hey guys, it's me Jaisal and I'm gonna present about speech recognition. Here's my topic and you all might know what speech recognition is and how it works basically and what it's used for. But what I'm gonna talk about today is I'm gonna talk about what it is, how it works in detail. I mean, not everybody knows the mechanism of speech recognition and the uses of it and the field or the area of technology where it's used. I'm gonna talk about how it works, the diagram of its working, and I'll explain you the diagram as well, and the applications, and in different fields of day-to-day life, the pros, advantages basically, cons, and then the references. And I have also input a short video showing how the recognition works. The mechanism basically, because that's the important thing that we need to know about the speech recognition. So the first question, what is speech recognition? So speech recognition basically means talking to a computer, having it recognize whatever we are saying. So for example, if you turn on the speech recognition on your computer and you say, hey, just tell me the weather today, and it should capture whatever you spoke and do some processes and tell you the weather or give you the weather report or maybe open the application which shows you the weather. The definition says that speech recognition is the interdisciplinary subfield of computational linguistics that develops methodologies and technologies that enables the recognition and translation of spoken language into text by computers. It is also known as automatic speech recognition, in short ASR, computer speech recognition, or speech to text SGT, which normally Google uses or many other applications use. For example, Siri, Alexa, Bixby, Cortana by Windows. These are some applications, some famous applications which use the speech recognition feature and provide help and support. And uh, yeah, yeah. So how does it work? We got to know what is speech recognition, but now it's the time to know how does it work. So this process fundamentally functions as a pipeline that converts PCM, so pulse code modulation, so whatever we speak, digital audio from a sound card into recognized speed. So it works on a principle of conversion of sound from whatever we speak to digital and then works accordingly. It basically uses algorithms through language modeling. It involves relationship between linguistic units of speech and audio signals. Language modeling matches sounds with word sequences to help differentiate between words that sound similar. So it has inbuilt language modeling and acoustic modeling inbuilt, and they try to search for similar patterns and try to frame a sentence or word or the command, and they also have inbuilt feature or characteristic which can differentiate or help them differentiate between the words that sound similar. For example, alphabet I and the word EYE, a body part. So they both sound similar when spoken or when pronounced. So the software or the system should know the difference between I, or when it's used, and how it can be framed in a sentence. We also use hidden Markov models. It's a model used to identify temporal patterns to improve accuracy. So some of like all the languages have some patterns or some slang, and the hidden Markov models and some other models are used to identify temporal patterns to improve the accuracy of the system and the feature itself. So here's the diagram showing how it works. So we speak something and it goes through feature analysis. It goes through the word match and sentence match, as I spoke earlier. The acoustic word models and the language model, they all contain unit model and lexicon, and the language model on the other side contains syntax and semantics. They are all inbuilt, and they all update themselves from time to time as you start using the feature. And the voice command or the sentence that you speak, it goes to the word match, sentence match. The system on its own comes to a conclusion, or the last command or the finalized sentence it should work on, or it should process or execute, and then it starts working on it. And the last sentence or the recognized sentence would be the concluded sentence by the system itself. Here's another diagram showing the same thing in a different way. So voice input then goes to analog to digital, that is the conversion. Analog is the sound or noise that we produce. It gets converted to digital and then goes to acoustic and language model, and then goes to speech engine. Then it displays to the users, or it works, or as I told, if you ask Siri to show the weather, it does not like tell you that you asked me to show the weather. It instead shows you the weather. So it depends on what the program is programmed to do. Here's the understanding of diagram, which I already explained you, that the speech is taken by the system and it goes through speech analysis, and the system matches the words and the sentences with the speech which it has taken in, and provides the best matched output. As we can see in the diagram, the word match and the sentence match the system uses is derived from the acoustic and language models we discussed in the above slides. Yeah, so the models that we are talking about, they're inbuilt and they get updated from time to time. And the feedback, I totally forgot about this feedback, sorry about that. Feedback is the thing that you can provide to the system if it makes any mistake, or the system itself uh, generates feedback if it thinks that it has made a mistake, and sends it to the manufacturers or the developers, and they make changes and update and correct the mistakes that they have made while programming the system or the feature, speech recognition feature basically. Here's the application. Here are the applications of speech recognition feature or the technology. As of now, speech recognition is not used at many places, but it is under development. In the upcoming short time, it would be used at many places. So the basic or the common speech recognition technology applications we have come across are Siri from Apple, and the others are Cortana in Windows, Bixby in Samsung, and Alexa from Amazon. Alexa is a personal assistant. You can so basically Alexa is a speaker you can put it at your home, connect it to internet, and if you speak anything or command anything saying that Alexa play me some music, so Alexa will play some music. It has a source, internet as a source, so it can go over internet and play your music for you from any website. You can also specify or mention any specific website you want to listen the song from. For example, you can say that Alexa play Thunder from Spotify, so Alexa will go on Spotify and play Thunder from there. The other features are called routing, speech to text processing. So for example, Google has its keyboard and many other phones have their keyboard as well, which support the speech recognition technology. So if you speak that, hey there, I'll see you by the river tonight, so the speech recognition or the voice recognition feature will process the voice you input in, and it will convert it to the text and show it on your screen, and you can send it or edit it if need be. And then comes the voice dialing and then voice search, so you can search for anybody using their voice. Car systems, so all the car systems have this feature nowadays. You all might have used it or come across it or seen in on videos, that if you say to the personal assistant that, hey there, call Jacob or call John, and it will dial or it will show you that it has two Jacobs in the phone directly list. Like, you gotta connect your device or phone to the Bluetooth system or the car system, and it will have access to all the information, and as you speak it will do the tasks while driving the car, so you don't have to do the things manually that distract you while driving the car. Then come the healthcare and military use for the speech recognition. Here are the applications continued. So we are all aware about how Google's speech to text conversion works. We speak something, it converts the speech into text and makes our task easier. Who doesn't know Alexa? Yeah, we all know Alexa, what it is and how it works, and everybody might have it at their location as well. We all know it. It puts the speech commands and does various tasks and provides information. Personally, I use Alexa for many tasks in my day-to-day life. I also ask Alexa to turn on my car with the auto start feature. Yeah, and I also tell Alexa and ask Alexa to do much more in my day-to-day life. Yeah, everybody uses Siri, Cortana, and Bixby in their day-to-day life every day for small tasks. And the cars nowadays have the speech recognition features as well as using which we can accomplish various tasks while driving the car. Yeah, we discussed about it already. Here are the pros of speech recognition technology. Well, there are many benefits of using the speech recognition system, as it seems like it has the ability to make our daily life tasks easier. We can use it to finish small tasks using it. We can tell Alexa or any other speech recognition software or the application to turn the lights off on, turn the car off on other basic routine stuff. We can accomplish various software tasks in computer and mobile devices, and more software are being used uh, as we go ahead, or day to day life, like many more software and applications are being developed using this technology and for this technology, so that the normal people or the users can use it for their benefit. Here's a short video of speech recognition technology. So it's the video of testing the speech recognition technology. So the man will ask the software or the guy in the on the screen to go ahead, stop, left, run, and such stuff. We'll see how the system responds to his commands. It said go forward, left, left, and it runs right, right, right again. You see, it stopped the movement as it was commanded to do so. And here's the cons of the technology or the speech recognition technology. Not the cons, but like it's still going through development, so it needs some feedbacks, and still it needs a few things it should improve on. So the technology is still under development, and sometimes it's still incapable of interpreting some commands and sentences. Depends on the surrounding it is located, and sometimes it might have background noises or disturbing noises, as a result of which it cannot interpret what the user is saying. It has not yet reached the level where we can accomplish complex tasks. When speech recognition encounters background noise, it is not able to provide accurate results. As a result of which, this feature technology is inaccurate sometimes, not all the times, but sometimes, and that's the place where it needs to develop. Here are the references that I used for the presentation that I made. Thank you for listening me. Thank you, and have a great summer ahead. Thanks. Bye.